بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 2.3, which is about applications in business about quadratic functions. So the total cost here is given by a quadratic function, and the revenue is given by a linear function, and the question find the break-even points. We will have the break-even points when we put the cost equals to the revenue, which means when we find the intersection points between the cost function, which is x squared plus 40x plus 2000, and the revenue function, which is 130x. This is a quadratic equation now. So to solve it, we take everything to the left-hand side. So we will have 40 minus 130, which is negative 90x, and plus 2000. Now, this is a quadratic equation. We can solve this equation either by factoring or by using the quadratic formula. By factoring, we can try to think of two numbers. Their product is 2000 and their sum is negative 90. And these are negative 50 and negative 40. If you multiply them, you get 2000. If you add them, you get negative 90. So either x is 50 or x is 40. So these are the number of units in which the break-even points would happen. If you want to find the break-even point, the y-coordinate and the x-coordinate, so you can use uh, either the cost function or the revenue function to find the y value. I'll use the revenue because it's easier. So 50 and 6,500, the first break-even point, and 40 and 5,200 is the second break-even point. The same question again, but the cost is quadratic and the revenue is quadratic in this case. To find the break-even points, I'll just put the cost equals to the revenue and solve the two equations together. So I'll have 0.1 x squared plus 35x plus 15,000. This is the cost written in the general form equals negative 0.9 x squared plus 385x, and this is the revenue also written in the general form. Now to solve this quadratic equation now, I have to take everything to the other to the left hand side. So 0.1 plus 0.9 would be 1x squared, and 35 minus 385 would be negative 350x. Okay, this is just x, and then plus 15,000 equals to 0. And again, this is a quadratic equation, and you try to factor this equation by thinking of two numbers. Their product is 15,000 and their sum is negative 350, or you use the quadratic formula. But if you try negative 300 and negative 50, their sum is negative 350 and their product is 15,000. So either x is 300 or x is 50. So these are the number of units when produced or and sold, we will break even. If we want to find the points, so we can just use either the revenue or the cost. I'll use the revenue because it has two terms, okay, to find the y coordinate. So replace x in the revenue function by 300, okay, and solve for y to get 34,500. And if you replace x by 50 instead of 300, you will give the value, you will get the value of y also, which is 17,000. So these are the two uh, break-even points. Here the profit function is given and it's a quadratic, and the production is restricted to fewer than 75. Well, this means that x should be less than 75, so we cannot produce more than 74, okay, 75 or more. Find the break-even point. Well, the break-even point, if the profit function is given, would be the zero of the zeros of the profit function. So we put the profit function equals to 0, and I did not write it. Let me, while I write it in the general form, I divide by negative zero point 0.1, okay? So when I divide by negative zero point 0.1, I'll get rid of negative zero point 0.1. So I'll have x squared, and 11.5 over negative zero point 0.1 is negative 115, and 150, negative 150 over negative zero point 0.1 is just 1,500. And now this is a quadratic equation. You solve it either by factoring or by quadratic formula. If you think of two numbers, uh, what about 115? If you multiply these two, you get 1,500. And if you add, you get 115. So either x is 15 or x is 100. But 100 is but 100 is greater than 75. Okay, 100 is greater than 75. He said that the production should be fewer than 75. So rejected. So this value of x is rejected, and the answer is 15. So this is the number of units when produced and sold. We get the break-even point. We don't have here the cost or the revenue function to find the y coordinate. If you replace x in the profit function by 15, you will get 0 because this is the 0 of the profit function. Find the maximum revenue for the revenue function. So we said that to find the maximum revenue, we must have a quadratic equation in which a is negative. Well, a here is negative 1. A is the coefficient of x squared, and b, the coefficient of x, is 1,600. And the maximum revenue would be the k, okay, the y coordinate of the vertex. So to find the y coordinate of the vertex, we need to find the x coordinate first, which is h, which is negative b over 2a. So it's negative 1,600 over negative 2, 2 times negative 1. And the answer is just 800. So h is 800. Now how to find k? K would be r of h. So r of 800. It would be 1,600 times 800 minus 800 squared. Okay, so what is the answer? Using the calculator, the answer is 640,000. So this is the maximum revenue. Okay, this is the maximum revenue. If in a monopoly market the demand for a product is, so this is the demand, which means the selling price. Okay, this would be the selling price of the commodity. And the revenue is given, of course, the revenue is, without, he doesn't have to tell this. We know that the revenue is the price times the selling price times X, the number of units, where X is the number of units sold. What price will maximize revenue? Well, what is the revenue first? The revenue is we multiply the price times X. So 1,600 minus X times X. So we will have 1,600X minus X squared. And to find, here he is asking about what price will maximize revenue. So he is asking about the price that maximize the revenue. Anyway, we need to find X first, okay? Well, X is the X coordinate, so it's H. So A here is the coefficient of X squared, which is -1, and B is 1,600 and H is the X coordinate of the vertex. It's -b over 2a, so it is 800. Okay, now 800 would be the number of units. 800 is number of units that maximize the revenue, revenue. Okay, he did not ask about the maximum revenue. If I want to find the maximum revenue, I just uh, replace X in the revenue function by 800 to find K. But he said what price will maximize revenue? So I need to find P. So P is 1,600 minus 800. So it is 800. So the price that will maximize the revenue is 800. Okay, it is $800. The profit function for a certain commodity is, this is the profit, find the level of production. So this is X that yields maximum profit and find the maximum profit. So the level of production is X, or we call it H, and the maximum profit is Y, or we call it K. All right. So A is -1, coefficient of X squared. B is coefficient of X, which is 110. H is -b over 2a. So the answer is 55. So this is the level of production that yields maximum profits. Okay. So 55 is the level of production that yields maximum profits. Okay, what is the maximum profit? Find the maximum profit, that's K. So K, we go to the profit function and we replace X by 55. So 110 times 55 minus 55 square minus 1000. And the answer would be 2025. So this is the maximum profits. Maximum profits. If the supply function is given by this equation and the demand function is given by this equation, find the equilibrium quantity. Well, the equilibrium quantity and equilibrium price, the equilibrium point would be when the demand equals supply. So we need to solve these two equations together. And to solve them together, the first equation is solved for P and the second equation is solved for P. So I can just say that Q squared plus 8Q plus 16 is equal to -3Q squared plus 6Q plus 436. And I solve this equation. This is a quadratic equation. I take everything to the left-hand side. 1 plus 3 would be 4 2q square. 8q minus 6q, that's 2q. 16 minus 4, 3, 6, that's negative 420 equals to 0. Well, I notice that I can divide by 2, so I will divide by 2, 210 over 2, 210. And now I either try to factor or use the quadratic formula to solve this quadratic equation. Here you have to use trial and uh, error method. Okay, you try, for example, uh, 2q square. You should write it 2q times q or q times 2q. It's okay, and then try to negative 210. Uh, Try to write it as product of two numbers. So, for example, negative 10 and positive 21, uh, negative 210. Now check that when you add the inner terms and the outer terms, you get the the term in the middle, which is correct. So these are this is the factored form, which means that either 2q plus 21 is 0, then q is negative 21 over 2, or q is 10. Well, q is the quantity. It cannot be negative. So this is rejected in real life. And q is 10. So equilibrium quantity equilibrium, let me call it like this, is 10. And now we need to find the equilibrium price. So the equilibrium price, okay, would be, you can find it either by using the demand or the supply. I will use the supply, the first one. So q square P would be q square plus 8 times q plus 16. So the answer is 196. So this is the equilibrium price. If the demand function is given by this quadratic equation and the supply function is given by this, find the equilibrium quantity and equilibrium price. Well, here the two equations are not solved uh, for P, all right? So how to solve these two equations together? You can look to the equations and try to find a nice maybe substitution, okay? You can substitute, you can solve one equation for one variable and substitute in the other. Well, I can see that from here, from this equation, if I take b squared to the other side, okay, then p squared is equal to 300 plus 2q. And if you put b squared now, if you substitute this in this equation, okay, in the demand equation, instead of p squared, if you write 300 plus 2q, so this is substitution, and I have plus 4 times q equals 1600. Well, this would be nice because now I have a linear function, a linear equation, not a quadratic equation. So that's excellent. 4 plus 2 would be 6q, and I'll take 300 to the other side. So 1600 minus 300 would be 1300. And now, if you just divide 1300 by 6, you will get q. 300 plus 2q, I put it here. 300 plus 6 q equals 1000. Yeah, excellent. So q would be uh, what? The 650 over 3. This is the equilibrium quantity. This is the equilibrium quantity. Well, to find the equilibrium price, you can use this one. You can use this equation, for example. So b squared would be equal to 300 plus 2 times the equilibrium quantity, and you will get 2200 over 3. And then P would be the positive or negative, uh, but it cannot be negative, of course, the price. So the equilibrium price would be the square root of this quantity, okay, which is uh, about, which is equal to the exact 10 times square root of 66 over 3. Okay, you can approximate that 27.1. This is the equilibrium price. Thank you very much. Study hard and have a nice time.